Hey folks, good morning. It is Tuesday, September 15th, 2020, and we're going to get to work on will be our daily math review. All right. First problem, we have to find the difference between 18,354 minus 4,672. And remember, you're not doing this on a Google form this week. You need to get out a blank sheet of paper and you're going to write your work on that paper and then you'll enter it here in this program. All right, so the first thing I want you to do is you need to write 18,354. Make sure you space those numbers out so you have room to regroup. Minus 4,672. All right, mine are nice and neat. Go ahead and find the difference to this problem. Okay, we did it correctly. You went 4 minus 2 is 2. Cannot do 5 minus 7, so I got to borrow 100. I now have 15, take away 7, and that is 8. I cannot do 2, take away 6, so I'm going to borrow from my thousands. I now have 12, take away 6, which is 6. Bring down my thousands, comma. 7 minus 4 is 3, and bring down my 1. So my answer is 13,682. Hopefully you did that correctly. Question number 2, I have to list the first 5 multiples of 4. Now remember, multiples are the products we get when we multiply numbers together. So if we're looking at the multiples of 5, let me rephrase that. The products we get when we multiply using the same number. So what I want to do is I want to find out what is 1 times 5, 2 times 5, 3 times 5, 4 times 5, 5 times 5. Now, the products that I get from these equations, they will all be the multiples of the 5 because that's the number that I use each time. So my answer would be 5, 10, 15, 20, 25. Okay? All righty. Go ahead and put that in your answers. And then let's move on to the next problem. Here you need to find the first 5 multiples of 7. So I want you to find those 5 multiples of 7. Go ahead and do that now. Okay, if I did this correctly, I said 1 times 7 equals 7. 2 times 7 equals 14. 3 times 7 equals 21. 4 times 7 equals 28. And 5 times 7 equals 35. So my answers would be 7, 14, 21, 28, 35. All right, good job. Okay, next one. Now you have to find the first 5 multiples of 6. Go ahead and find this on your own. All right, if you did this correctly, you should have gotten 6, 12, 18, 24, 30. Because 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18, 4 times 6 is 24, and 5 times 6 is 30. Okay, next one, we have to check all of the following multiplication problems that have a product of 32. That means when I multiply these two numbers, the product is going to be 32. Okay, 1 times 32, yes, anytime thing times 1 is itself. That's that identity property. 2 times 16. If I don't know that in my head, I can take 2 and add it. 6 plus 6 is 12. Carry my 1. 1, 2, 3. Yes. But it's 4 times 8. 4 times 8 equals 32. So I'm going to mark that. 6 times 6. 31 times 1. 11 times 3. 16 times 2. And 8 times 4. Okay, I want you to go ahead and finish this out and mark your answers. All right, if you did this correctly, you would have chosen 16 times 2 and 8 times 4, which if you notice, they're the inverse up here. Remember that linear property, you can multiply, flipping the numbers and it's the same. This would not be correct because it's 36. This is not correct because it's 31. This is not correct because it's 33. All right, next problem. This is one of those reasonable answers. Does this answer make sense? Sometimes we come up with an answer and we don't stop and we think back, does my answer even make sense? Make sure you do this. So we're going to do lots of problems like that here. If your neighbor's dog barked the last 4 Mondays and Thursdays, is it reasonable to think that the dog will bark next Monday and Thursday? Reasonable or not reasonable? And explain your reasoning. So if the neighbor's dog, for the last 4 Mondays and Thursdays, it would bark. You think it's going to bark next Monday and Thursday? What do you think? Go ahead and put down reasonable or not reasonable, and I want you to explain your reasoning. We'll discuss this when you come back tomorrow. The next one, mental math. Try to do this in your head. If you still need paper and pencil, that's okay. You're going to start with the sum of 3 and 5. Add 8 plus 4 minus 2. Add the number of days in a week. Subtract the value of a penny. Add the value of a nickel. And now you should be on the number of days in what? Okay, go ahead and solve this. Now, let's see if you got it right. The sum of 3 plus 5 is 8. Now I'm going to add 8. That's 16. Now I'm going to plus 4. That's 20. Minus 2, 18. Add the number of days in a week. That's 25. Come up here. 25 minus the value of a penny is 24. Add the value of a nickel, which is 5 cents, and I get 29. I should be on the number of days in what? Well, April has 30 days. February has 28 days. There is no such thing as April in a leap year. But I know that every February has 28 days, but then on a leap year, it adds one more day. So my answer would be this third one. Now, something else that I want you to kind of pay attention to. See how I use this arrow to bring that 25 up? That kind of lets me know that's all part of the same problem. So if you run out of space, draw yourself an arrow to where you picked up on your problem. Alrighty, folks, and that is, the thinker question. A frog is in a 20-meter deep well, and it jumps up 3 meters each day, but it falls back 2 meters each night. At that rate, how many days will it take the frog to reach the top of the wall? Hint, make a drawing to help you. So for me, folks, I kind of made a big old deep well. All right. And it was 20 meters. So from here to here, it's 20 meters. And I know that he went 3 meters up each day. And I know that he went 2 meters down each day. Guess he just wasn't strong enough to hang on. I don't know. Now, the question is, how many days is it going to take him to reach the top? All right. So, maybe draw yourself a picture, draw a ruler, maybe you can use that, I'm not sure. Think about what strategy would work best for you. And then once again, we will go over this when you come back to class tomorrow. All right, that's it, folks. So hope you had a great afternoon, and I absolutely cannot wait to see you tomorrow in class.